Okay, here's the trig functions test review problems. So we'll start out, we got a round pizza cut into 10 slices, the diameter 12 inches. So basically we got a pizza, diameter's 12, and cut into 10 equal slices. So we'd have 5 cuts through there. 1, 2, 3, 4, 5. Oops, I think I already had the one for the diameter. We can count that one. So there's 2, 3, 4, 5. Okay, something like that. So basically we need to figure out the central angle there for each slice. So basically it's kind of dividing the full circle up into 10 angles. And we need to do this in radians because that's what's going to make the arc length and all that stuff work. So we'll see that in part B. But basically the easy way to do this, if the full circle is 2 pi, right, 360 degrees, it's cut into 10 slices. So we have 10 angles there, right? I mean, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're all the same, hopefully, even though my drawing wasn't that great. But each angle would have to be in radians, the full 2 pi divided by 10, or of course we could reduce that down to just pi over 5. Okay, so that'd be the angle measure in radians. So now the question is, what is the length of the crust of each slice? Okay, so here's the crust. So think about this. We have basically the radius of the circle. This is one slice kind of magnified here. If the diameter's 12, right? So from the center to the circle, the radius is going to be 6. Okay, this radius is also going to be 6. And our crust here is actually going to be the arc length. And a lot of times they use S to measure arc length. And we know the angle in here, we just found in part A, is pi over 5 radians. So the relationship is, if you remember, the arc length will be 1 if kind of the definition of a radian, I guess, is what I'm getting at. But what it boils down to, the arc length always equals the angle times the radius. Okay, and the angle must be in radians. Okay, if you think about if that angle was like 50 degrees or something, what would it be? It would be 36 degrees, right? If we were measuring in degrees, the 360 divided by 10, 36 degrees times the radius of 6 is going to be way bigger than this length, right? But if you keep your angle in radians, pi over 5 times 6, that will work out. So that's kind of the shortcut, I guess, is just know the formula. The arc length, sometimes they call that S again, is always the radius times the angle in radians. So in this case, the radius was 6. The angle we found in part A was pi over 5. So this whole thing is going to be 6 pi over 5. Okay, and if you calculate that, it's approximately 3.77 inches. Okay, so either one of those would be fine. So that would be that green arc length there. Okay, couple conversion problems. Remember, we just have a conversion factor here. If we want to go, it's all based on pi radians equals 180 degrees. So we're just going to multiply by some ratio here of, in this case, I want to end up in degrees. So I want the 180 degrees on top, the pi radians on the bottom. And then if you just do the calculations there, notice the pi's will cancel out. So I can basically see the 35 times 180, and then when you divide by 18, you should end up with 350 for that one. Okay, number 6, other direction, we start in degrees. So in this case, I want to multiply by pi over 180. So basically what it's going to boil down to is just reducing. It's going to turn out to be 600 pi over 180. And we like to keep these as fractions. So just kind of reduce the 600 over 180. And the shortcut, the trick on your calculator to do that is if you want to go, I'm just kind of ignoring the pi for a second. Just to reduce a fraction, if you haven't seen this, you can go 600 over 180. And then go into the math button here, and there's going to be a fraction, and it's going to give it to you in simplest form. So we're looking at 10 over 3. And then just throw the pi back in there. 10 pi over 3 should be our final answer for this one here. Okay, so B for that one. Okay, finding exact value of a trig function, that's really big about what the unit circle does. So you can either use special right triangles or use the unit circle. So I'm going to kind of set up a little sketch for each and set up where the unit circle would be. So basically the 120 I know is going to be in quadrant 2. Okay, I know that it is 60 degrees short of 180. So there's my 120. Okay, that reference angle again is 60 because that's what would form the triangle here. There's my reference triangle. Okay, so if we can think about what the coordinates of the point up here would be, we will then know the sine and cosine. So again, this one, it's not one of the 45 reference angles, so the root 2 over 2's are not a possibility. It's either going to be the root 3 over 2 or the 1/2. So what I usually think about is that this one is, it's the higher angle, right? 60 is the taller between the 30 and the 60. So it needs to have the larger y value. So the y value is the bigger one. It's the root 3 over 2. The x value is the half, but in this quadrant it's actually negative half. And then from there we can get all of the trig ratios. Okay, the x is the cosine, the y is the sine. Okay, if we need tangent, we do sine over cosine. Here we actually need cotangent, right? So cotangent is the reciprocal of tangent. So cotangent is the cosine over the sine. So if we just know those two values from the previous step, there's cosine divided by sine. We can see the 2's will actually cancel, okay? Or technically we're multiplying by a reciprocal, right? It's negative 1/2 times 2 over root 3. So the 2's cancel, and we end up with this, okay? Because those 2's divide out. And then we just rationalize that, times top and bottom by root 3. And we're going to end up with negative root 3 over 3. Okay, so D is your answer for that problem. Okay, number 5, cosine of negative 45. Again, let's draw a little picture. Negative angles, all angles start this way, but negative means we're going to go clockwise. So we're going to end up down here with 45 degrees. Okay, and then we can, again, think on the unit circle. 45-degree reference angle, those are the ones that are all of the root 2 over 2's. And this one being a fourth quadrant means that the y is negative, but the x is positive. So root 2 over 2, negative root 2 over 2. And then we just need the cosine, which is just simply the x value there. Okay, so this one should be C, positive root 2 over 2. At the sine of 360, so again, if we think about where that ends up on the unit circle, we always start here. We need to do a full rotation and end up right back where we started. So the point right there on the unit circle, that's the one with the 1, 0. And the sine, of course, is just the y value, so the sine of 360 is 0. And then cosine of 240. Okay, 240, if we think about starting here, there's 90, there's 180. I know all the way down would be 270, so I'm basically going 30 short of that. So this little piece is 30, but our reference triangle is always up here. So the reference angle in this case is actually 60. Okay, let me move this down a little bit so we can draw the full triangle out of it. Let's make the point down here. Here's my reference triangle actually, okay, with the 60 up there. So in that case, this is the 60 is the reference angle, so the y value has to deal with the root 3 over 2. Okay, so the y coordinate down here in the third quadrant is negative, and it's root 3 over 2. Because again, that's much lower than where the 30 reference would be. But the x value is also negative in the third quadrant. Okay, so then when we are asked for the cosine, we just need the x coordinate. Okay, negative 1/2. Okay, moving on here, they're giving us a point in standard position. Okay, they're telling us where the angle goes through. So let's draw this out here. Okay, so we know basically, there's my xy axis. I'm going through 8, negative 6, so I'm down in the fourth quadrant. I'm just gonna try and keep it neat and not put all the tick marks, but we're somewhere down here. Okay, standard position is always gonna go this way. So technically this angle is this entire big thing. Okay, that's actual theta. Okay, really big angle, right? It's above, it's more than 270. It's somewhere roughly 300 and some degrees. The reference triangle, though, is here. Okay, that's a right angle. Well, this right here is my reference angle. I'm going to call it theta and put a little prime there. Right, theta prime is the reference angle. Just to notate that it's separate from theta, but it's related to theta. So that's what that little apostrophe, it's a prime. You'll use that a lot in calculus. But anyway, so what we know on this triangle then is the adjacent side here, the x value is 8 from the green theta prime, that's the adjacent. The opposite's the y. In this case, it's a negative number, it's a negative 6. Okay, and we need to find our hypotenuse. Okay, so it's just going to be straight Pythagorean theorem. R squared is always x squared plus y squared. Okay, that's just, remember, that's just a squared plus b squared equals c squared. We just call them different things. So if you check that out here, r squared will actually be 8 squared is 64, negative 6 squared is 36. Those add to 100, so r ends up being 10. Okay, that's our hypotenuse. And then we're able to now write the ratios. Okay, the sine of the angle is opposite over hypotenuse, negative 6 over 10, which we just reduced to negative 3/5. The cosine is the adjacent, 8 over 10, which we reduced to 4/5. And then your tangent is opposite over adjacent, negative 6 over 8, which we can reduce to negative 3/4. Okay, now how do we find the actual angles? Okay, the reference angle, the green one, in the triangle. Okay, think about this. We know that the tangent of that reference angle is negative 3/4. Okay, so to get theta prime, we're just going to do an inverse tangent on both sides. Just need a negative in there. Right, so some old stuff there. That'll get us the angle in the triangle, the reference angle. So make sure we're in degree mode. This is a calculator problem. Just double check your mode. Yep, we're still good in degrees. So I'm going to go ahead and do the inverse tangent of negative 3/4. Okay, and you just got to watch because this actually gives you a negative angle based on where we're at. But that's basically like the absolute value of the angle. So we're going to go with around 36.9 degrees. Okay, in the triangle itself, the angle is 36.9. Okay, so that's this angle here. Okay, which again is this angle right here. Okay, so what would that make the entire yellow angle, the actual theta? Okay, the standard position measurement. So think about basically we went 36.9 degrees short of doing a full circle, right? So the actual angle would end up being 360 minus that 36.9, which ends up giving us an angle of around 323.13 degrees. Okay, the other option, if you wanted to, you could say technically it's negative 36.9 degrees, but just the way standard position goes, I mean, I guess that would be, either one would be acceptable. You could say or negative 36.9. Okay, because again, standard position is just saying that make sure you start here, and you can either go clockwise 323, or you could go, I'm sorry, you could go counterclockwise 323, like the way the yellow one looks, or you could actually go clockwise 36.9, which is technically negative 36.9. So either one's fine for that. Alrighty, number 9, quadrants, where are we at? So I need basically this, if the sine is positive, we need to remember the sine is the y values. Okay, so the y values are positive, either in quadrant 1 and quadrant 2. Okay, and the cosine are the x values. So where are the x values negative? Quadrant 2. Okay, so quadrant 2 is where both of those things are true. All right, what about the second one? Tangent is y over x. Okay, so where is that negative? Okay, it's going to be negative where the y and the x are different signs where, you know, one's positive and one is negative. So that happens in quadrant 2 and quadrant 4, tangent's negative there. And then cosecant's the reciprocal of sine, right? So cosecant deals with y values too. So where are the y values negative? In quadrant 4, 3 and 4, but to make both conditions met, quadrant 4. All right, and then our trig graphs, we have 2 cosine, 2 theta. We need the amplitude and period. Okay, so basically the first two there is the amplitude. It's going to give us our height from the center. The period is going to come from the b value. Okay, this one didn't specify degrees or radians, so I'm going to stick with degrees just because it's a little easier. There's my b value. The period is always the 360 divided by b, so in this case 180 degrees. So let's set up our scale and we'll get our graph in here. Okay, so we always do the 4 tick marks. I'm basing all of this entire graph on these 4 points. Okay, we have a 1, 0, a 0, 1, a negative 1, 0. Okay, and in this problem we're dealing with cosines, right? So cosines are going to be our x values. So I'm really just looking at these 4 points as we go around. Okay, and the best way I found to do this, since the period on this one's only 180, that's going to be our last number out here. Okay, this is equivalent to a horizontal compression, right? This whole thing, it's doing its whole wave, its whole cycle in 180 degrees instead of 360. So we're just going to change the scale on the x and then draw this like a normal looking cosine graph. Okay, so if we think about the first tick mark here is usually 90, but everything is getting divided by 2 or scrunched in, so that's only 45. And then you can just keep adding 45s. All right, now our amplitude being 2 is going to set up my height from the center. Okay, and this one doesn't have any shifts going on, so we can just graph it and be done with it. If we think about cosine, over here, it usually starts at 1. Okay, but since everything's being multiplied by 2, ours is actually going to start at 2. Cosine then works its way down to 0, then works its way down all the way to negative to the bottom, back to 0, and then back to where we started. And we just kind of need to round off the edges because this thing's going to keep repeating itself, but we have shown a complete full cycle there. Okay, number 11, in radians, I see we have a couple shifts going on. So basically, the scale, let me see how I want to set this up. We have enough room to go 1, 1, 2, 2, 1, 2, 3, 1. Okay, we need our 4 evenly spaced tick marks. Now notice the b value here, there's like a 1 in there, so we're using the full period of 2 pi. Okay, that's the 360 basically. So these are going to be the radian of 90, or pi over 2, radians of 180, and radians of 270. Okay, now also we don't have any amplitude change, so it's just going to be the standard 1 as well. So my advice on this one, do the standard parent function. Let's do that in green here. I'm just going to graph y equals sine theta. And then we'll talk about the 2 shifts at the end. Okay, so the standard parent function, okay, I'm going to make this 1 and make this negative 1. Okay, a regular sine graph right here starts at 0, goes up to 1, back down to 0, down to negative 1. So it's going to be in the middle of my labels here. And then back up to 0, and it kind of goes like this. Okay, and again, let's do this dotted or do it lightly in a different color. This is like an intermediate step. Okay, because now we have to worry about the shifting that's taking place here. We have a plus pi over 2, and we have a plus 1. So all of those points, think about you have 5 points. They're all going to get moved. And they're all going to get moved. The plus pi over 2 is actually going to take us left pi over 2. And the plus 1 on the outside is going to take us up 1. Okay, so let's do this and see what we get. Gotta get this out of the way because we need to shift left and that's gonna be in my way. Okay, so that was 1. So this point here is actually gonna shift left pi over 2. So it's gonna end up off our graph, so we'll just kind of approximate, but it's gonna go over and it's gonna end up about here. Okay, this point right here, if it goes left pi over 2 and then up 1 is gonna end up over there. Okay, this point is gonna go left pi over 2 and up 1. It's gonna be where the old one was. Okay, this thing is going to be left pi over 2 and up 1 and be where the old one was. Okay, this one left pi over 2, up 1 is going to be here. So our new graph is kind of doing something like this. And we may want to extend this out here a little bit just so we can show what's going on. This would now be, it was originally at 0 and it went left pi over 2, so it's technically negative pi over 2 now is the x value there. Okay, and that would be it. So the period and amplitude on that one, again, we said the amplitude was 1 because there was no change. The period, there was no change, so it's really like 2 pi over 1, which is just still 2 pi. Okay, that's the time it takes to do its entire cycle. All right, and the last one, we need to write the equation and get the amplitude from a given graph. So here's my thoughts. I think if we find the midline here, okay, the center, I can see this thing goes down to -3 and goes up to 1. So the center is actually at -1. Okay, that's actually going to be the vertical shift, excuse me, because normally these are centered through the x-axis. But this one, again, notice the height where it goes up 2 and down 2 from that dotted yellow line. So I know my equation is going to have a -1 on the end for a shift. Okay, so what about amplitude? The amplitude of this one from that center, I can see that we are again going up 2 and down 2. So that's my amplitude. The amplitude is 2. That's going to be the a value in the equation. The period, how long is it taking to do a full cycle? Okay, so let's track that. So if we kind of start here and do a full cycle, that looks like a full cycle, then it's going to start to repeat itself. So the period is the standard 360 degrees. Okay, so that tells us something. Remember the equation always says that the period is always 360 over b, right? So in this case, our b value has to be 1. Okay, so that's good because it's going to make our equation a little easier. Now we just need to decide, is this a sine curve or cosine curve? So if we think about the way the graphs look, and we move along, there, and there, generally cosine would start at 1, sine would start at 0. We're not starting at 0, so I'm thinking it's probably some sort of a cosine curve. Let's see if that works. Cosine, if we started with a cosine, and again, it's going to be a negative cosine though, because we're actually starting at the bottom. Okay, a typical cosine would start at the top and go down. Think about the x values, decreasing, decreasing, and then that increase. So we're kind of just doing the opposite thing. We're from here to here, we are kind of increasing, then decrease. So this is a negative cosine curve. We know the amplitude we said was 2. Okay, and then basically our period being 1 means that there's no b value in there, it's just theta. And then notice where the yellow dotted shift was actually a downward shift of 1. Okay, so that should be our equation. Okay, so just kind of piece it together, and hopefully that helps.